What's going on today, YouTube? Today I want to talk about my voice assistant that I've been working on, Project Vivi, and just some thoughts that I've been having about it. So a couple of days ago, or about a week ago, I was thinking about the project and I was like, okay, cool. I can have the assistant talk back to me in any personality that I want. I can have it, I can design it a certain way. I can prompt it a certain way, blah, blah, blah. You know, typical ChatGPT stuff. I can do all of that with it currently right now, but one thing that it's currently lacking is context of the user and memories of the user. So the whole concept of memories for a chat assistant or for a voice assistant really started bugging me. I was like, shoot, well, in order to create a voice assistant that is, that is more personal, you want to have the voice assistant remember who you are and to be able to pull up relevant information about you. So I know that sounds a little bit creepy. I know a lot of people might not want that, but I do. I want to see how a voice assistant, how I can talk to a voice assistant yesterday and have it remember about the details that I talked about it yesterday, and also have it remember about something that I talked to it about a month ago. And so that is, I don't think there's a solution to the issue right now, and that is one thing that's currently being researched, and I'm taking a look into it because I want to add that type of functionality into my voice assistant, because I think that would be pretty cool, to have a voice assistant AI that can remember who you are, can remember conversations, and depending on how you see it, you can think it's cool or you can think it's creepy. But I had a little bit of a brain dump that I want to just share and just document for documentation purposes for the project, and let's jump into it. Okay, so I called this long-term memory for a chatbot, and so I had kind of just this random memory dump. I was just typing everything that came to mind, and so, you know, it's a lot of gibberish and stuff like that. So I went ahead and had GPT-4 summarize it so that I could go over it. So overall I had 8 points. So the analysis, and then I had it analyze the points. So I'm going to go through each one of these points. And these are all things that I talked about in my brain dump. So the first issue that I analyzed or thought about was long-term memory for chatbots is a problem due to token limits and high costs when using GPT architecture. I don't think this is wrong. Token limits might go away as we start seeing higher and higher token limits of 8K and 32K for GPT-4. However, that does not eliminate high costs. So in order to ask a chatbot about a query for something that happened a month ago, I don't want to be charged $20 because it's trying to analyze all of the files and all of the tokens for that. So yeah, that it says is accurate. GPT architecture struggles with long-term memory due to token limitations and associated costs. I don't think token limitations is too much now, but associated costs definitely. Research on improving the architecture to handle long-term memory can be found in works related to memory augmented neural networks and transform models with external memory. So looking into these right now. 2. A different approach is needed to have chatbots remember previous conversations without processing entire logs. This is pretty accurate. Alternative methods are needed to reduce the computational burden and costs associated with processing entire logs. So once again, this is the same concept of, this is the same point of right here. High token limits and high costs. We can't have we can't have a chatbot go through literally everything that you've talked to it in order to scour it for the information it needs. That's inefficient. And 3, storing full conversation logs and creating executive summaries for each log can help chatbots recall specific information. So it says that this is accurate. Creating executive summaries can provide a condensed version of conversations, which allow chatbots to recall key points more easily. And then it says research on abstractive and extract text summarization techniques can be helpful in this regard. The fourth point is that chatbots can reference executive summary logs to continue conversations and access full logs when more detail is needed. Accurate. By referencing executive summaries, chatbots can continue conversations based on key points without needing to process entire logs. If more detail is required, the chatbot can't access the full log. And so, you know, it says that this balances computational efficiency and information retrieval. Cool. The fifth point that I made was GPT architecture may need customization to enable semantic decision making for selecting the best memory. And this semantic decision making is deciding what memory to pull based on what the user is asking in order to best suit whatever the user is trying to ask for. So I guess what I'm trying to say is it's not just a yes or no. It's taking a lot of different values into the big picture to give you the best response based on what it's thinking about. I guess the way that I can relate it is if you're telling it that you have a friend and that you want to give them a present, it might reason that it's their birthday, so it might give you ideas for a birthday present. I think that's a simple representation of what I see as semantic decision making. And so what it says down here is that GPT architecture does not inherently support semantic decision making for memory selection, and then adapting the architecture integrating with external memory systems may be needed to achieve this functionality. Cool. So the sixth point is multiple completion points. Multiple completion lists could be used to determine whether a user is asking for memories and parse through them. So this kind of idea that popped into my head was that maybe I could have multiple different ChatGPTs analyzing the files. I can maybe have a main ChatGPT continuing the conversation, one to analyze the files, and one to judge what the user is asking for. And so this is a very cumbersome way to go about it. So it says this is plausible. While it may have merit, a more efficient and robust approach could be to train a classifier to determine whether or not a user is asking for memories or not. This could help simplify the memory retrieval process. So I kind of have a vague idea of what a classifier is, and that is something that can group things together, based on memories or based on what the user's asking and the information it needs to retrieve. I still have to do some more research on what those are. And then I started coming across a couple of other things, a little bit more jargon, I guess, in the field. So like vectorization and cosine similarity. So vectorizing text files and using similarity measures like cosine similarity may help find relevant conversations based on user input. And it says this is accurate. So vectorizing text files and using similarity measures can help identify relevant conversations. Research on information retrieval techniques such as term frequency, inverse document frequency, and word embeddings can provide insight into finding the most relevant content. So I think this is pretty interesting. I had never really thought about it this way, but I guess what you can do is you can vectorize text files. So once you get a vectorization, a decimal value or floating point value, you can do the dot product of them and then divide them by the magnitude of the two vectors that you're dot producting, and that'll get you the cosine similarity. So depending on how large that number is, decides the similarity. A lower number means that they're very similar. A larger number means that they're not too similar. So that cosine similarity basically just kind of tells what angle is between those two vectors. So if you have one going up and you have one going diagonal, those points are not together. But if they're parallel to each other, those text files might be related. So you might want to grab those for the conversation. So that's the way that I understand cosine similarity. And then there are so many different other things to go on for this type of retrieval process that I still need to do some more research on. And then point 8, it says it may be possible to vectorize dates to help chatbots retrieve information, to retrieve conversations based on when they occurred. And it says this is plausible. Vectorizing dates can help in retrieving conversations based on their chronological order. But it says, however, additional research is needed to determine the effectiveness of this approach. Alternative strategies might include using time-aware embeddings or leverage metadata associated with conversation logs. So I still have to do a little bit of research on like the metadata part of it and the embeddings part of it, but I believe there are some GPT models. There's one called Text Embedding ADA 002 or something like that that allows you to do these type of embeddings. And that's what I want to go into a little bit more research about. So a couple of days ago, which was crazy because I was just thinking about this type of stuff, a YouTuber that I watch, his name is David Shapiro. He introduced this idea of hierarchical memory consolidation system, HMCS. I like this name better, REMO, rolling episodic memory organizer. REMO just flows better off of my tongue. This kind of goes through a system on this kind of goes and outlines a system that is inspired by human memory processes for like recall and memory organization, and he wants to use it, or he proposes that we can use it for artificial, or I guess he says autonomous cognitive entities to manage and optimize internal memory. So I'm not going to go through this entire thing. You can go read it if you are interested. But basically what this is, what the hopes are of these thoughts are to be able to integrate memory systems into AI assistants. And so what was really cool is like the day yesterday or something like that, this person right here, Kai B3R, came up with a project, Emergent, that implements this idea. So I am still reading through the code and trying to figure out how it works. If we take a look at the example conversation, we have him and then we have the agent. So he asks the conversation, "Do you remember me, David? I'm Bob." "Yes, Bob, it's good to hear from you again. How can I assist you today?" "Prove you remember me." "Of course, Bob. We have interacted before, and based on the information I have in my memory, you are a 25-year-old resident of somewhere with 4 siblings. Is there anything else I can help you with?" "What is HMCS? Explain it to me." HMCS stands for Hierarchical Memory Solidation System. It's a system that is being developed to improve efficiency and effectiveness of large language models like ChatGPT. The system aims to mimic human-like memory organization and recall, enabling efficient storage and retrieval of information while adapting to grow data. So it says who's the user, and the user is Bob. So that was an example of this idea of the chatbot being able to remember who the user is and to be able to recognize and pull relevant data. So this is all really interesting, and this is what I want to incorporate into my Vivi project that I have here. So I mean, this is basically like my voice assistant that I want to be able to use for solving problems and to be able to converse with in order to further my thoughts. And to do that, you need to have memory in the system, or else it's just going to be a blank new conversation each time that you have to tell prime, and you have to prime it each time for what you talked about. So that's going to be a part of the project that I want to incorporate. And yeah, that's just what I wanted to talk about today. I know it's just a lot. So if you actually stay through this entire voice dump of the YouTube video, then thank you very much. I will be, looking more into this and releasing more details on how I incorporate it into Vivi. So yeah, stay tuned for that. But I'll catch you later, and see you later, everybody.